Hello friends, this is KM Majan from Godavari College of Engineering, Jalgaon, working as a system professor in Department of Mechanical Engineering. So today we are going to discuss about design of a centrifugal clutch. So first of all, what is clutch? What is the definition of clutch? So as you know, clutch is in a machine membranes which is used to connect the driving shaft of a machine primer of an RC engine or an electric motor to the appliance driven shaft. At the wheel of operator means engagement and disengagement of the driving shaft with the driven shaft is carried out with the help of a clutch. Okay, and in figure here you can see a single plate clutch is shown there, and you know it's better how it was. So let's know about the types of clutch. So basically there are two types of clutch, positive clutch and friction clutches. Basically these are classified into two categories, that are positive clutches and friction clutches. In positive clutches, the torque or motion on the driving shaft is transmitted with the help of the jaw clutches, that are positive clutches, means by means of a direct interlocking of the jaws on the driving shaft to the jaws on the driven shaft. A positive or direct interlocking is there. Because of that, the motion, power or torque is transmitted from the driving shaft to the driven shaft. And as per the shapes of the jaw, these positive clutches are classified into two types, that are square jaw clutch and spiral jaw clutch. The second type is the friction clutches, in which we find three types of clutches are there, that is plate clutch, cone clutch and centrifugal clutch. So today we are going to discuss about the design of a centrifugal clutch. So here in this figure you can see a simple schematic of a centrifugal clutch. So this is the front view of the centrifugal clutch, and you may say this is the side view, from side view how it looks like. So again, the two shafts, this is the driving shaft and this is the driven shaft. So you can see here the driven shaft is in the form of a pulley. Okay, a pulley rim is mounted over the driven shaft and which is rigidly fixed to the driven shaft. Okay, on driving shaft you can see here one spider is there, you cannot see here, but inside view you can see it, a spider, or you may say guide is there. So in this guide there are four different shoes which are mounted on this spider or guide, and that shoes can moves radially inward or outward. Okay, all these shoes are held in their position by means of spring, means an tension spring is applied there to hold that shoes uh, on their position when the clutch is not in working with the help of the springs. On the top side of the shoe you can see a friction lining is there. Here in the side view also you can, front view you can also see the friction lining, and these are the springs, these are the shoes. Here in this case the four number of shoes are shown here. Okay, and now how it works and why it is called centrifugal clutch. So as you know, centrifugal force, the definition of centrifugal force, that is whenever a mass is being revolving on a circular path, then a radially outward force acts on that mass and which try to throw the mass away from the radius of rotation, that is called centrifugal force. And the magnitude of this centrifugal force depends upon the mass of the substance which is revolving on the circular path. At the same time, angular velocity or speed of that revolving mass, then radius of rotation of that mass. Any out of these three factors increase, the centrifugal force also increases. So let's see how it works. So as soon as this driving shaft starts rotating, all the four shoes which are mounted over this driving shaft also starts rotating, and because of that rotation These shoes are possessing some masses. So and centrifugal force comes into action, and which acts over all these four shoes, and because of that centrifugal force, all these shoes starts moving radially outward. They do not move until the magnitude of the centrifugal force uh, increases beyond the spring force. Means whenever the magnitude of this centrifugal force exceeds the spring tension, at that time they starts floating or moving moves outwards. So when the shoes moves outwards radially, so they are pressed over against this rim. This is the rim. These are pressed over this rim, and because of that pressing and frictional resistance is developed in between this shoe lining and this pulley rim. So the whatever the motion and torque is available on this driving shaft, that is transmitted to the rim of this driven shaft because of this frictional resistance. So a frictional force comes into action here or working of the clutch. Means the torque is transmitted from the driven shaft driving shaft to the driven shaft with the help of a frictional resistance developed in between the shoe lining and the inside of the pulley rim, and because of that the torque is transmitted from the driving shaft to the driven shaft, and this frictional resistance is developed because of the centrifugal force acting over this all four shoes. So that's why it is called centrifugal clutch. So let's see the design of a centrifugal clutch. So here in this figure you can see one shoe of the centrifugal clutch is shown here. This is the shoe, and the portion of a pulley rim is shown over here. Okay, now let's see all the different parameters which are shown in the figures. So this capital R is the radius of the pulley rim, then the small r is there, that is the distance of CG of the shoe from the center of the pulley. So this is the center of gravity of the shoe, and this is the small r, which is the radius of the center of gravity from the center of the spider or center of the clutch. Then PS, this is the PS, this is the spring force by which the shoes are held on their position. Then PC, small PC, so this is the centrifugal force acting on the shoes. After that F is the frictional resistance developed in between this brake shoe lining and the pulley rim. Then L, so this is that L, so it is the shoe length. Okay, then B is not shown over here in this figure because actually you can see the B in the plane which is perpendicular to the paper of this figure. So here you can see this B. So theta, it is the, here it is the theta, the angle subtended by the shoe lining at the center of the spider. And M, let M be the mass of the shoe, N number of shoes. So small n, here in this figure you can see there are 4 number of shoes, so we are assuming here there are n number of shoes. Now let T be the torque transmitted in Newton mm, let P be the intensity of pressure in between the shoe lining and the pulley rim, N is the running speed of the pulley, N1 is the engaging speed of the pulley. So from this N and N1 you can calculate omega and omega 1, that is omega is the angular running speed in radian per second and omega 1 is the angular engaging speed in radian per second. So let's assume that this omega 1, that is the engaging speed, is 3/4 of the running speed. So that is our assumption here. So we are assuming all these quantities. So let's find out the torque transmitted by a centrifugal clutch. As we have assumed T be the torque of that torque which is transmitted by the centrifugal clutch. So we know centrifugal force acting on a shoe can be given by m omega square r. So this is the standard formula to give the centrifugal force. m omega square r. So force exerted on each shoe by the spring. So let ps be that force. So here it is shown that ps is equal to m omega 1 square r. So this already we have assumed this omega 1 is 3/4 of the omega. So putting the value of that omega 1 here as 3/4, so you will get 9 by 16 m omega square r. That is the magnitude of this ps. Now the net outward radial force by which these shoes are pressed against this rim can be calculated by pc minus ps. That is the difference between the centrifugal force and the spring force, because both of these forces are acting in opposite direction. Here you can see in this figure ps and this is your pc. Okay, so if we put the magnitude of pc here m omega square r and ps 9 by 16 m omega square r, so we get the net radial outward force, that's 7 by 16 m omega square r. Now once we get this net outward radial force by which the shoes are pressed against the rim, you can calculate the frictional resistance developed in between that shoe rim and the shoe lining and the pulley rim. If we assume mu be the coefficient of friction between the uh, clutch, shoe lining and pulley rim, so simply multiplying by mu with the net radial outward force, that is pc minus ps, you will get the magnitude of this frictional resistance, that is f. Now if we multiply this frictional resistance f by an radius of the pulley rim, you will get the torque transmitted by because of the frictional resistance. So here you can see, and if you multiply it by the number of shoes, then you will get the total torque transmitted by the n number of shoes. So by this formula nfr, in short, f is the frictional resistance and which is given by mu pc minus ps. Okay, and r is the radius of the pulley rim. You will get the torque transmitted by the centrifugal clutch. So from this formula of torque transmission, you can get the mass of the shoes. Okay, now let's find out size of the shoes. Already we assume L is the length of the shoe, that is shown over here. So you can calculate this length of the shoe if you are knowing the magnitude of this theta and the radius r. Okay, so simply r theta will give you the arc length of this sector, If you assume this theta, generally this theta is taken as pi by 3 or 60 degree, so it will be r pi by 3. Now area of the shoe lining, already we have assumed again small b is the width of the shoe which is in the plane which is perpendicular to the plane of this paper. So area will be L into B. Now the force with which the shoe presses against the rim can be given by multiplying the area of the shoe multiplied by the pressure intensity in between the shoe lining and the rim. So this will give you the net force with which the shoes are pressed against the rim, A into P. Putting the value of A into P here, A is LB, so we will get the net force LBP. Also the force with which the shoes press against the rim is given by PC minus PS. Therefore PC minus PS can be equal of the net force with which the shoes are pressed against the rim. So PC minus PS should be equal to LBP. So from this formula you can find out the size of the shoe, and as we are knowing the spring force is given by PS is equal to 9 by 16 m omega square r. So the spring can be designed with this usual procedure. Already we know the spring design. So designing a centrifugal clutch means nothing but simply we have to find out the mass of the shoe. Okay, mass of the shoe, then size of the shoe, that is length and width, then we have to design the spring. So if we finalize all these design parameters, that means we have designed the centrifugal clutch. Okay, I hope you must have understand. the design of a centrifugal clutch. So thanks for watching, and don't forget to like and share this video if you like it. Thank you very much.